called chemical equations and reactions. So in this video, we will be learning how to make a balanced chemical equation informative. So before we continue this video, please subscribe, share, like and comment. So here, how do you make a chemical balance equation informative? You all know what is a balanced chemical equation, right? That is, different types of atoms from the reactant is equal to the number of atoms in the product, right? That is, LHS is equal to RHS. So how do you make it more informative? Like how do you tell, like, if this, what is this element? Is it a solid? Is it liquid? Is it aqueous solution? So how to make it like that? So there are two things you have to learn. Indicate the physical state of that reactant and the product, both sides. You have to indicate that physical state. Second thing is heat change. If it's undergoing exothermic reaction or this or other type of changes, right? Other thermic reactions. So how do you write that in equation? So first, how do you indicate physical states? So there are symbols which indicate physical states, like S stands for solid. That is S. Liquid stands for Li or just L. Then aqueous solution, aqueous is for AQ, and gas is for G. So these are the four states you have to memorize for writing a balanced chemical equation. Without these states, when they ask a question that you have to balance this equation, if you don't write these states, you won't get the marks. So, memorized? Now next is heat change. So, what does heat change mean? Like if it's going exothermic reaction or endothermic reaction, how do you tell like that? So when it's exothermic reaction, the product receives a plus heat. So let's say the reactant is here, reactant. Another. Let's write X plus Y. Let's let X be the X and Y be the reactants. So let's try X plus Y is equal to X Y. Gives you this. So how do you take this as exothermic? That you have to add plus heat, because exothermic is giving out heat, right, or producing heat. So you have to write plus heat. But if it's endothermic, X plus Y in heat gives you X1. Or this you can put or X plus Y plus heat gives you X1. Either this you can write S plus Y, arrow above you can write heat, or X plus Y plus heat plus XY. Heat also can be in energy form. So plus energy or just energy, anyway. But you have to write either these three. If it's, this is for exothermic, exo, and here is for endo, exo. Now we'll be writing the examples. Okay, so for the examples for this, indicate physical states. As you already know, solid is S, liquid is L, aqueous is AQ, and gas is G. So here is two examples. Zinc plus H2SO4 gives you zinc SO4 plus H2. So how do you put the states? So zinc is reacting with this H2SO4, which is sulfuric acid, with zinc SO4 plus H2. H2 is hydrogen. Here H2 given here is gas, and here zinc is solid. So what are you gonna write? Here you'll be writing here bracket S. Here bracket H2SO4 sulfuric acid, which means it's aqueous solution, right? So you have to write here AQ. Here zinc SO4. This SO4 is here and SO4. So this means this is also aqueous solution, right? So again here AQ. Then H2. It has a 2 here. Like O2 is a gas, right? And H2 here is gas. So what will be the symbol? Yes, G. So here G. Now next example, Mg plus O2 gives you MgO. But first you have to balance this, right? Because it's not balanced, right? 1, 2, 1, 1. Not balanced, no? So how do you do? Add 2 here, you will get 2 here, 2 here, and another 2 here, 2, 2. So hence balanced. Now, what you are going to do is you have to write states here. So O2 obviously will be gas. Then what will this 2Mg? It will be solid, right? So here also you will be writing S. Then here MgO. You know there is a reaction, you know, when magnesium burns with oxygen, it gives you magnesium oxide. So it will be in the form of what? Will it be solid or gas? Solid, right? So here it will be solid. So now next is heat exchange. So heat change. So here are the two examples. C plus O2 gives you CO2. So first we will do with the balancing, right? First with the change the states. So C will be solid, right? So right here S. O2, which means gas, and CO2. What happening? What's happening? It's turning to gas, right? So here also it become G. So think, is there exothermic or endothermic? Exo, right? How? Because C plus O2 is combining to give up heat, which also forms carbon dioxide, which gives you CO2 plus heat. So this is exothermic. Exo. Now next example, N2 plus O2 gives you N. But it's not balanced, right? Here 2, here 2, here 1, 1. So not balanced, right? So easy to do, just multiply here with 2. So balanced. Now N2 and O2, which means both of them are gases. So which means this is also gas, right? So here, yes. Now think, will it be exothermic or endothermic? How is it performing this gas? It's undergoing heat, right? It's burning. So this one will be either you can, I'm going to put here heat. It's your choice if you want to put plus heat or heat above the arrow, your choice. Either way, you have to write the heat in the correct side. If you write in the wrong side, you are not going to get that point. That point will just go back in the bin. Now next we'll be learning the types of chemical reactions. So we're going to learn 5 types of chemical reaction. So what are the 5 types of chemical reaction? First one is combination reaction. Second, decomposition. Third, displacement. Fourth, double displacement. And last for redox reaction. So combination reactions are 2 or more reactants which form a single product. So here is an example. X plus y gives you xy. As for decomposition, decomposition is where a single reactant forms into two or more products, which is xy gives you xsy. Now displacement reaction. Displacement is xy plus z gives you xy plus x. So here x is less reactive than z, which is why it is displacement. So xy turns into zy because this removes x and goes in y, and x is already. Next, double displacement. xy plus wz gives you wy plus xz. How it is x goes with y, x goes with z, and w goes with y. So the displacing, that is why it is called double displacement. Next is redox reaction. But the reaction is both oxidizing and reducing. You will understand more clearly with a few examples. Let's go with examples. So here Mg plus O2 is MgO, right? But is it balanced? No, right? Here one is here one, here two. So what should we do? Just balance it. Right here 2 Mg. So this is equal. But here also has to be equal. So 2 Mg. Now what are the states? Here will be solid, gas, and solid. Right? Now this is combination reaction. And now for this Fe plus S, ferric iron plus sulfur gives you ferrous sulfur, sulfide. So nothing to balance, right? No. But so what states? Here will be solid, here will be solid, and here solid as well. Now decomposition reaction, which is xy breaks into x plus y, where one reactant breaks into or decomposes into two or more products. So here the given examples, CaCO3, that is also known as limestone, breaks into CaO plus CO2, where CaO is known as quicklime or just lime plus CO2, which is carbon dioxide. Anything balanced? No. So yeah. Now AgBr gives you Ag plus Br. 2. Here to balance this, right? Here 2 is there, but nothing to it, so add 2 here, which will give you 2, add 2 here, and it's balanced. Now this AgBr is solid, so solid here, and here Ag, so this will be solid because it stands for silver, and Br2 means it's a gas, so it is vaporized, so it will be gas. See here CaCO3, it is decomposing under heat, so which forms CaO plus CO2. So since this is a thermal decomposition, you should write heat here and decomposition. For now, I am writing deco, but when it's exam time or test time, you have to write decomposition. And another thing, for this combination matter, this one, you have to write here combination. So for now, I am just going to write com, but exam time, remember, write full name. His full name, combination, and here decomposition. Now next is displacement. So xy plus z gives you zy plus x. So this is displacing. So here we give an example, Fe plus HCl gives you FeCl2 plus H2. So here H is less reactor net ion, which is displacing it to form ferrous chloride, and here forms a gas. So the states are, here is solid, here is aqueous, here forms aqueous as well, but here forms gas. So you understood? Now double displacement. So here it is given xy plus wz gives you wy plus xz. So this guy here will go here, right? We saw now, x goes to the z side and w goes to the y side. So which forms wy plus xz. So in the given example here, NaOH plus HCl. What does it give you? NaCl. It is taking this Cl. NH. This is hydroxide now, and hydrogen, which will form, what is hydrogen plus hydroxide is water. So the H2O will be liquid. NaCl will be what? What will be? Aqueous, right? So here will be aqueous. NaOH also will be aqueous, and here also aqueous, right? Should I balance everything? No, no. All looks the same. Now next example is this AgNO3 plus NaCl gives you AgCl plus NaNO3. So here what is shown is this Ag is displacing NaNO3, which Na is thrown out and goes with Ag's ex-girlfriend. So he exchanged his girlfriend. So Ag hangs out with chloride and Na hangs out with NO3. Hence gives you AgCl plus NaNO3. Now next and last of all, redox reaction, which means it is reducing and oxidizing at the same time. How? Here is given example H2S plus I2. I stands for iodine. I gives you high plus S. It's not iodine, it's Hi. So what should we balance here? So H2, I2, which gives you I2 here. So multiply. H2S, what will be? It will be aqueous, right? Because it's, so it will be aqueous. And here will be gas. So here Hi, which will form solid, right? Hydrogen iodide. So solid, and here solid as well. Next, zinc plus C stands for carbon, gives you zinc plus carbon monoxide. So this reaction is similar to, it is displacement reaction, because it basically is familiar, right? XY plus Z gives you XY plus X is what we are seeing here in these two examples. And another thing, combination decomposition. They are actually opposites. How they are opposites? Here they are showing reactants. Two or more reactants is forming to one product. But here, one reactant is forming two or more products, right? So this guy and this are opposites. I'm just going to write here output for now. Now, of all these examples, the metals present are all the solid. Exception is mercury. So, and all these non-metals, right? Either they can be in liquid state, this gaseous state, or solid state. But the only non-metal who is liquid in form is bromine. But basically what happened in this decomposition reaction, it was supposed to turn into liquid, right? But it is decomposing under the presence of sunlight. So this is, you have to write here light, and write over the decomp here. So it is undergoing photolytic decomposition. What is it? Photolytic decomposition. So this is formed, it still was formed under the presence of sunlight and giving out bromine vapors, which means bromine liquid present in this EGBr is forming into vapors. So usually bromine is in the form of liquid, but here since it's undergoing light or photolytic, it turns into vapors. Now the bromine is a part of a halogen. So what are the halogens present? The first halogen is fluorine, and the second halogen is chlorine, and the third halogen is bromine, and the fourth halogen is iodine. So these are the four halogens. I mean, there's a lot of halogens present in the periodic table if you look at it, but for now, in this year, we've just been learning 4 halogens. So remember the 4 halos. I think some of you might be familiar with the game, right? So think of them as the 4 players in this year, 4 halogens. So what are the 4 halogens again? What is the fluorine, bromine, chlorine, and iodine. So yeah. Now you're all clear. Redox is similar to displacement. So it's like they're the same but with different names. But the process is same. The reaction is similar. But here this H2S is getting what? Is it oxidizing or reducing? Oxidizing, right? Because it's removing the hydrogen out. So it's remove hydrogen, go. So he's alone. And this hydrogen now goes out with iodine. So oxidization is what? Adding of more oxygen or removal of hydrogen. And for reduction, it's removal of oxygen and adding of hydrogen. So, as zinc oxide plus carbon, here the zinc oxide is getting reduced and the carbon is getting oxidized. So, you understood? Thank you. Please subscribe, share, like and comment.